How you doing, guys? This is just to add on to the video on 11b. I'm just doing question 11 separately. It's quite long. So we're on page 197. We're just looking at question 11 by itself. The question says a particle of mass 8 kilograms is describing a circle with constant speed v on a smooth horizontal table. It's connected by a light inextensible string of length 3 meters to a point which is 1 meter vertically above the center of the circle. Okay, so what we're looking at here is 3 meters of string, 1 meter of height. Okay, and there's our radius there, which we can find using Pythagoras. So here's the path that our particle is going to follow. Show that the tension of the string is given by T equals 3v squared. The particle will remain in contact with the table if the velocity is less than 8g, and that the speed of the particle is, if the speed of the particle is increased to root 9.1g, calculate the height at which the particle rotates above the table. So let's start off with our triangle here. We've got 3 and 1. So this is going to be root 3 squared minus 1 squared. Root 8 is our opposite side here. This angle is going to be important as well. So we can see straight away that sine theta is going to be 1 over 3. Cos theta is going to be root 8 over 3. Over 3, excuse me. Now, if we look at the forces acting, we've got the tension, which we're going to resolve into components inwards. Okay, and that's going to be, I'm going to write over R there. That's going to be, if that's theta, it's going to be T cos theta inwards, and the same upwards tension, I'll show it acting here, or here, it doesn't matter, is going to be T sine theta. Maybe if you saw it there, the sine might make a bit more sense. We've also got the weight, which is mg. Okay, we're on a table here. Okay, so we have a reacting force as well. So maybe I should have put T sine theta here, and over here I'll show the reacting force. Okay, they're all upward forces anyway, so they'll go together. So that's the supporting force of the table. To start with, our particle is not crashing through the table or moving upwards. It's stationary in the up-down direction, which means forces up have to equal forces down, as usual. Okay, so our upwards forces are the reactionary force plus T sine theta have to equal mg. And sorry, we're told it's an 8 kilogram particle, so that's 8g. So our inward forces then has to be our centripetal force as usual. So our force in is equal to our centripetal force, and our inward force here is just whatever that component of the tension is. T cos theta is the inward component of the tension. Now, because the question is going to ask us about velocity in parts 1 and in 2, I'm going to work with the velocity version of centripetal acceleration, which is mv squared over r. And we know that the radius is the square root of 8. So this equation here, I'm going to call A and B. Equation A is going to say R plus T sine theta is 1 over 3 equals 8g. And equation B is going to say that T cos theta, root 8, over 3 equals m, I apologize, should have gone in as 8 there as well, because we know that the mass is 8. 8v squared over root 8. Okay, so cross multiplying here, we get t root 8 by root 8 equals 3/8 are 24v squared. So 8t is 24v squared, and t is 3 v squared, which is what they asked us to find in part 1. So there's part 1. Showed the particle will remain in contact with the table if v is less than 8 root 8g. In order to remain in contact with the table, you need t sine theta to be smaller than 8g. And just at the point where it lifts, or it starts to lift off the table, those two will be equal. At which point the table is providing no upward force. You could pull the table away and the thing would keep spinning around in the plane it's in when you get to this particular speed. So we have this equation here, and what we're interested in is the point just when r equals 0, and when we need just our tension to be a little bit less than 8g. Okay, so we need 8g to be we need t over 3 to be less than 8g. Okay, well, we have an expression for t over here, that's 3v squared, so that becomes 3v squared over 3 needs to be less than 8g, or v squared needs to be less than 8g. Okay, taking square roots on both sides, v needs to be less than root 8g, which is what they've asked us. The third part of the question says if the speed of the particle is increased to root 9.1 g, okay, so we're now higher than this, calculate the height at which the particle rotates above the table. So as you spin faster and faster, you can imagine here the thing wants to come up more and more as it spins around. When it's at just the right speed, it'll spin around in a horizontal circle. So this is nearly a full new problem. What we're looking at now is the same string of length 3 meters is at some unknown height above the table, and therefore some unknown radius of rotation. It's still spinning around in a circle, so we're still twirling this around in a circle, and its velocity now is root 9.1 g. The forces acting are still t. This angle has changed, okay, because this side has changed. The angle that we're looking at has changed. So the horizontal component of the tension is now t cos, and I've called that alpha, but it's cos of a different angle. And this is going to be t sine alpha is the vertical component. You've also got weight, which I should have maybe not put the velocity there, but anyway, our weight is still 8 times the acceleration due to gravity. So where do we go from here? We say, first of all, this triangle here we're going to have to work with. So we look at that triangle there, x, r, and 3, and there's alpha. We can say cos alpha is the radius over 3, sine alpha is x over 3. Okay, so our first equation, forces up equals force down, is going to say t sine alpha equals 8g, which is the same as t sine alpha is times x over 3, where x is what we're trying to find here, equals 8g. Our second equation of motion that says the forces in are the cause of the centripetal force. That's why we are moving in a circle at all. So that t cos alpha is equal to your centripetal force. Now they've given us something in terms of velocity, so we'll work with the mv squared over r because they gave us something with velocity. Well, let's develop that. T cos alpha is r over 3 equals m is 8v squared over r. Now take that a little bit further. If I cross multiply, t r by r is r squared equals 24v squared, and r squared, what we're trying to do is to get x. I'm sorry, v squared, excuse me, it's 8 times root 9.1 g squared all over r. So rather than go with that, let's try this again. TR over 3 equals 8 times 9.1 g over r. And yeah, okay, cross multiply TR squared is 24 times 9.1 g. We're trying to get x, and because we know 3x and r, we can use Pythagoras to write x in terms of, r in terms of x. So specifically Pythagoras here says 3 squared equals r squared plus x squared. So r squared equals 9 minus x squared. Okay, when you move that x squared over. So let's replace that. That says t by 9 minus x squared equals, let's see what 24 times 9.1, well, let's leave that actually, 24 times 9.1 g. Okay, the reason I'm going to leave that is I'm about to get an expression for t from this first equation and plug it into this second one. So that one, if I multiply through by 3 and divide through by x, I get t equals 24g over x, and I can sub that in down here. So I get 24g over x times 9 minus x squared equals 24 times 9.1 g. So straight away here we've got a common factor of 24, which is nice, and a common factor of g. So 9 minus x squared over x equals 9.1. Cross multiply. 9 minus x squared equals 9.1x. Move everything over. Let's do that down here. We're going to get ourselves, so when I move that over, it becomes plus x squared plus 9.1x, and then move the 9 over, it becomes minus 9. All that equals 0. So we want to solve this quadratic here. So I'll do that nice and quick. X is minus 9.1 plus or minus the square root of 9.1 squared minus 4 times 1 times minus 9 all over twice 1 minus 9.1 plus or minus the square root of, well, let's see, that's 9.1 squared plus 36. 9.1 squared plus 36 is 118.81 all over 2. The square root of 118.81 is 10.9. So minus 9.1 plus or minus 10.9 over 2. Now, because x represents a distance, a negative answer won't make much sense here. So I'm just going to finish this off up here. So we'll just take minus 9.1 plus 10.9 over 2 to get ourselves our positive answer, which is 10.9 minus 9.1 is 10.9 minus 9.1 is 1.8, and then divided by 2 is 0.9. Okay, so x equals 0.9. Just be a little bit careful in this question. They haven't asked for how far below the ceiling are we, or wherever the string is suspended. They've asked us for calculate the height at which the particle rotates above the table. So our answer here is 1 meter, the height that the string is above the table, minus 0.9. So 0.1 meters. Okay, see you next time.